In this related rates problem, we read that the total resistance R in a circuit where two resistors R1 and R2 are connected in parallel is given by 1 over R equals 1 over R1 plus 1 over R2. Okay, so there's the relationship between them. When the circuit is turned on, R1 increases at 0.6 ohms per second and R2 increases at 0.3 ohms per second. Okay, so they're both kind of kicking in. How fast is the total resistance R changing when R1 is equal to 80 ohms and R2 is equal to 110 ohms? Okay, so what do we know? Well, we know the equation. 1 over R equals 1 over R1. Whoops. Wow, don't know why I did that. 1 over R2. We know that dR1 by dt, sorry, I was about to write that differently. My head was jumping ahead here. dR1 by dt is going to be 0.6. And that's going to be ohms per second. Okay, we know dR2 by dt is going to equal 0.3 ohms per second. Okay, and we know that what we're interested in is how fast. In other words, what we want is dR by dt, the overall resistance. But at the moment that R1 is 80 ohms and R2 is equal to 110 ohms. Now there's likely to be a bunch of people out there that say, Mr. Clausen, why aren't you using the proper symbol for ohms there? Ask, because not everybody's going to be familiar with that. And you don't actually have to know much about physics to understand how to get the answer to this equation. You just need to know the calculus. So I'm not going to worry so much about the notation there. Okay, so we're going to jump right in. We're going to start with our equation. So 1 over R is going to equal 1 over R1 plus 1 over R2. And so here we go. Probably actually would make more sense for us to write these like this. That's going to make this a little bit easier for us to work with. Okay, if we don't deal with it in terms of those reciprocals there. Now this becomes negative R dr by dt, negative R1. Oh, I'm sorry. To the negative 2, to the negative 2, dr1 by dt. Sorry, I forgot about that. You got to bring down the exponent, subtract 1. I just forgot to do that, and that's okay. Minus R2 to the negative 2 dr2 by dt. We have to take the derivative implicitly because all of these things are changing with respect to time. Okay, so now we are looking for dr by dt. Now this is the same here as negative 1 over r squared. So I'm going to multiply up by that. So this is going to become dr by dt when I isolate that. And I hope what I'm about to do here makes sense here, because this is the same as kind of 1 over r2, sorry, 1 over r squared. Okay, there's a negative there. So I'm going to multiply this up. So the negative will cancel here, and we're going to be left with, this will be r1 squared, r squared in the numerator, dr1 by dt. And then the exact same thing is going to happen here. That negative is going to cancel with this negative. This is like having r2 squared in the denominator, and I'm going to bring up r squared into the numerator, dr2 by dt. Okay, good. So now I'm at this point right here. Now it's just a matter of evaluating, really. Okay, I know R1 is going to be 80 ohms, that'll be squared, and I know dr1 by dt is going to be 0.6. Oh, what I don't know is the actual overall resistance. So I'm going to have to go through and spend a couple of minutes and get that right there. And actually that's going to be the same issue over here. I know that R2, actually I don't need the parentheses there. I know that R2 is going to be 110 ohms. Again, I don't know the overall resistance. I couldn't tell you. And dr2 by dt is going to be 0.3. Okay, so I got to figure out what the overall resistance is at this particular instant here. So when we know that we've got 80 ohms on R1 and 110 ohms on R2 here, so I know this will be 1 over that resistance will equal 1 over 80 plus 1 over 110. Okay, now I'm just going to actually do this on my calculator here. I will let that machine handle this, and then I will convert. And so what we're going to get here is that 1 over R is going to equal 19 over 880. So R, if I reciprocate the left-hand side, I got to reciprocate the right-hand side. So that's going to equal 880 over 19 ohms. That's the resistance I'm looking for overall. So now I'm going to come over here, we're going to plug that in. So this is going to end up being 880 over 19 squared. 880 over 19 squared. This will be over 80 squared, this will be over 110 squared. Now, I could do this in exact form, but you know what, I've got some decimals in there already, so I'm just going to go through and evaluate this. So on my calculator, 880 divided by 19, that's going to be squared, divided by 80 squared, and this is all multiplied by 0.6, plus 880 divided by 19 squared, divided by 110 squared, multiplied by 0.3, and the answer is, to the nearest hundredth, 0.25 ohms per second. That's how fast the overall resistance of that parallel circuit is changing, is increasing.